Good morning, everyone. Can you hear me clearly? Apologize for the late start. Some students were confused where to meet, so let's wait for those students. Good morning. All right, so this is my chosen platform, and I explained previously why I like it so much. I have to apologize. I didn't send you the syllabus or I didn't prepare the Moodle page. We're fine. You know, last week was just the first class, and I hope that didn't irritate anyone. But we're going to go through this together, and I'm going to ask you to look at least at the Moodle page right now and download the notes. You can put them on a screen, or you can, you can just put them on the screen. I'm going to work with the annotated notes, and you can follow along. So I believe the Moodle page is now up to date. I've included information about the tests, and I've also emailed you the syllabus. So really, this is our first class. Last class was just a touching base class. I asked you to watch those videos. I didn't check. I can actually check how many views there were. I just hope that you all took the opportunity to watch them so that today's discussion can go rather smoothly, that you are following along, that you're getting the most out of the lecture, okay? So these are the notes we're going to work with today. I'm wondering if I should say something about the syllabus. Maybe I'll do a little bit of that while you're getting the notes. All right, you can see my Moodle page. Okay, Liliana, the difference between the annotated and the other set of notes is that the annotated notes have comments, answers to questions. It's like your clave. Okay, so the idea of having the regular notes is that you don't know the answers in advance. If you follow with the annotated notes, you have the answers there. All right. All right, so this is the Moodle page that I've finally set up. Had to think about a lot of things and how I want to do this for the class. I'd like you to, the syllabus is there. I'd like you to read through the Code of Honor and agree to it. Okay, so that's the commitment to integrity, practicing integrity for this course. No cheating. It's basically it. Plagiarism, anything like that. So that your work is your own. However, I do encourage you to work in groups. I just mean for the tests. The quizzes that I have online, which I will be allowing you unlimited attempts, I'm not... those should be primarily your own, but if you consult with other students about errors you made or with me, that's fine, okay? But for the test, that should be individual work. Let's talk about the tests, because I need you to agree to the tests. So this is what I've outlined for the test. Remember, if the screen gets blurry, just refresh your page. Or if what you're viewing is not matching with what I'm saying, refresh your page. All right, so I've set up the tests as 3 tests, and I'm going to have them on the Saturday of the lecture, but they're only an hour and a half, so it can be either, and we can have a vote right now. I post the test for after the class, where we can use the class for review or for anything. I mean, I probably need the lecture to keep up with the topics, so I don't want to waste the class on tests, but I want to have enough tests, and I want to spread them out so that I can monitor and you can get your feedback more than just once, right? You're going to have 3 opportunities before the final exam, so that's the idea. They are going to be online, and they will be multiple choice, so they'll be like the tests, there'll be questions like the tests that are provided in Moodle and in the homework, multiple choice type questions. And they should take you, well, they'll be for an hour and a half, so they should take you about 40 minutes to complete. I'm also allowing you to write up answers on separate pages, which then you can email to me just as a, in case there's some misunderstanding and you, in reading the problem, and you deserve part marks, and I'll consider them. But you have to send me those within 15 minutes of submitting the test. So the tests will be like the quizzes in that it's the same platform. I'm going to use the quiz activity button that I have. So if you do the quizzes, you have an idea of what it's going to look like on the test. So I'll make sure the test questions are all on one page, but they will be random, so everyone has a different test. Any comments or questions? So my idea is to have the class and then have the test. And if you insist, I can end the class early and allow half an hour for the test, so then it's not it's just an extra hour on that day for writing the test. The grade will be automatically, the test will be automatically graded, so you'll get the result right away. In the previous 2 semesters where we did distance learning, I was trying to grade papers and it backed up, and students really wanted the feedback, and I think this will be the best compromise. Any comments? So we'll have the class from 9 till noon, and maybe I'll stop at 11:30 and post the test. Well, we'll take a break. I'll post the test at maybe 11:45. So you get 15 minutes to take a little break and then write the test. So that way during the class you can ask questions. We can review new material. And at the very least, if students don't want to attend the class and they want to study instead, which they might want to do because they're nervous about the test, you'll still have the class to review after the test because there'll be a video for it. No comments? So we're going to proceed like that. Okay, so we'll have class till 11:30 on those days, and then at 12:45 I'll post the test. 11:45. Okay, I'm going to post it. I can post it for 2 hours, but it should only take about an hour to do. So those will be heavy days. I think it's the best way to deal with this material. All right, okay. But they should take 1 hour to complete. If students want to start later, they want to take a larger break, or they want to study longer, that's up to you. But once you start the test, you only have until that time to finish it. So you can use all the materials at your disposal, just not the help of another human being in real time. You can watch videos, in other words. You can't ask direct questions. All right, so you seem in agreement. Anyone who doesn't, you guys can email or text me your concerns. Yeah, if you want to send me a private message, you can send it to my phone, and I'll try and see it. I have my phone. I have a lot of screens to look at, and I have the sound off on my phone, but I'll try and catch it. Okay, so this is where we're starting. Everyone knows where to get this, so you'll find this in the platform. I'm going to work with the annotated. Let me take a moment to check my emails to see if anybody's having trouble getting in. If the slides look blurry, refresh your screen. Refresh your page. That's just a YouTube thing. I don't know why that happens. It's not my end. All right, I'll make this bigger. Right, and the test will be posted in Moodle like the quizzes, and I'll have a heading that says tests at the top of the Moodle page, like right under that stuff there. I'll put them. I'll show you, hold on. So I'll put them up here. So under these top headings here, I'll put it right under for tests when it's test day. And it'll look like the quizzes. You'll just click and then you'll have to agree to start, and then you start the quiz or you start the test, and all the questions should be on one page. All right, so let's start with a discussion about statistics, like an overview about statistics, and then we'll get into what is data and data collection and good methods of data collection. So what is a statistic? Give me an example of a statistic, please. Ordering you around. Or give me an example of a statistic. In baseball, we use RBIs. What does that stand for? I'm sorry. I'm not a sports person. I don't know what word to use. Okay. A statistic. A census, unemployment level, a sample, okay? Okay, so yeah, keep going and then I'll explain. And you can decide how close you were. Runs batted. RBIs. Runs batted in. Okay. So that's the same as a home run. So now I have a baseball expert in class, or fan. The COVID numbers over time. Okay. Okay, so you guys have some ideas. All right, so before I go to the definition of a statistic, why do we study statistics? What's the idea? What is the point of a statistic? And why do we study statistics as a discipline? No comments? So you watched the videos, you got an idea there that we want to know in a very uncertain world, what to expect. So to alleviate uncertainty, and maybe and possibly reduce risk, we want to predict what happens, right? What's going to happen, what's coming, what's around the corner. My writing is terrible today. Okay, so to alleviate uncertainty and possibly reduce risk, we make predictions, right? So we make predictions about what to expect. So I'm debating whether I'm going to focus on COVID because this could go too far. But okay, let's say we want to know something about a population. It could be people that are infected with COVID or another condition. Contagious condition. So that could be my population. Now, can I, think about it, can I really identify all those people? I don't know who's infected. How are we going to figure out who's infected? Are we going to test everybody? Because now we have to think about budget constraints. Is that even possible to test everyone? And how good are the tests? Questionable. These PCR tests are not supposed to be used on people that don't have symptoms or are not at high risk because they risk false positives. So how do we assess this? We don't even know who the infected people are, right? So what we try and do is get a sample. So we can't even get that. What we could do is we could find in a population, we could take a sample and see how many are infected. That's not, identifying all the infected people, but using a sample, so people who work in the healthcare system directly with patients, all kinds of patients, and we can use a symbol for the population size, and we usually use a symbol N, big N, large N, capital N, to denote the population size. Now we might not know it, right? We just say healthcare workers, and it's probably too expensive to get at everyone. But let's take a sample from them. With sample size, and now I use the symbol little n to denote the sample size. So these are universal notations used in textbooks and in reports. Okay, so you can be comfortable with it even on in software. Sometimes they mix up the big and the little n. That bothers me, but this is usually the standard. And large N is reserved for the population size and small n for the sample size. And what we do is using the sample, just draw it like this. So in the video you had, you know, this is the population. They made like a, let's say that was a population size. And then you draw a sample, which is just a part of the whole, right? So you get that part. Statistics are numbers computed from the observations in a sample. That's what a statistic is. So hopefully you're going to be a little more careful with the use of the term. I don't know why things get separated. I got to figure this out. No, they get separated. Oh well. All right. So a statistic they're numbers, or statistic is a number computed from the observations in a sample. So the observations need to be numbers if I can compute a number, right? So that's what a statistic is. You can't see that. Driving me crazy. I don't know why that happens. Let's see. Now you can see that? It's like they updated the software and I have to figure out how to use it. Okay, so that's what a statistic is. So given that, what is it for? And what's a good statistic? A good statistic is depends on its ability to estimate the characteristic in the population of interest. So numbers of interest computed from the observations or the values in a population are known as what? I'm reading your chat. Okay. Okay, you guys, anybody? So numbers computed from observations in a sample are known as statistics. These statistics are meant to estimate what? You guys know the word, but you just don't know if it applies here. I imagine. It's a word that people use very loosely, and that's why I'm distinguishing it here in our discussion, because it has very specific meaning in statistics. Known as parameters. Okay, so it's a parameter. So we're going to use the term parameters in statistics to talk about the actual or true value. So some words for that would be the true value or actual value. Sometimes it's known, sometimes it's unknown. We don't really know what the infection, the number of people infected in the population is. We don't, but we can try and estimate it, and we study statistics to develop better and better estimators, okay? Okay, so that's the distinction between statistics and parameters. So statistics are as good as the data they came from. So the data has to be collected properly in a representative way, meaningful way. And then, depending on that, it will be a good or bad estimate of the parameter. Okay, so some examples of statistics. You guys wrote out some examples. So, there we go. Or let me just write it like this. So in statistics, and most of you took statistics probably, right? Most of you took statistics. Some of you remember, and some of you don't. And other people haven't taken statistics at all. So that's fine. We're starting from scratch. You can tell by where I'm starting with these definitions. So an example of a statistic would be the sample mean. Now, I'm being very precise here, and you'll see people are not so precise when they write reports or when they make statements. But if it comes from a sample, any mean or average is a sample mean. Okay, so that's the promedio in Spanish. And that estimates it's meant to estimate the population mean or the population average. These are all the same thing. Population average or the true mean. These are all the same, have the same meaning. Okay, and so we're going to spend this course talking about statistics, which are numbers computed from the observations in a sample. And the idea of statistics is to estimate the parameter. So this is, some people have written inference. This is the idea of inference, using statistics to infer what the parameters could be. You'll notice, I'm going to write it down. So this is inference. You'll notice at the beginning what happens with this course, like I'm going to talk about data first, but then what's going to happen is I'm going to tell you what parameters are, and we're going to sort out what we can expect from a sample. If I already know the parameters, is that a practical exercise? Well, not really. But we're going to use that exercise to build a bridge between parameters and statistics, and then take the bridge backwards in a more realistic approach of saying, well, I have some statistics I got from a sample. Let's guess at what the parameters could be. So that's where we're going with this course. We're going to work on the bridge for half of the course, and then we're going to take the bridge backwards with inference. So some people have written, someone's written about the other kinds of statistics. Sure, other statistics. I don't know why I can't. I have to practice this. I don't know what's happening. All my writing is being dislodged. All right. So we're going to I'll do this on another slide. This is fine. I'll just leave it like this for now. Okay, so that says true mean. So someone was saying some other examples of statistics are the sample median. Now nobody says sample median. They just say median, but you got to be clear about what that is, right? The sample median, again, is meant to estimate the true median. Okay. All right. Questions? Comments? So you can establish, to what degree you were right or wrong or what you were missing in your description of what a statistic is, but then you gave me an example of statistics. So when you mention a statistic, you need to mention what what it intends to estimate. Well, obviously, just if you say the word sample, then it's covered. Okay, so sample mean, sample median, etc. All right. Oops. Back. All right, so the goal of statistics, and if it seems like I'm going too fast, just take a screenshot. And thank you for all your comments. The goal of statistics is to gain information from data about a variable. Okay, I didn't use that word exclusively, but a characteristic or variable, we'll talk about that, so that we can better understand what to expect. The types of data. Any characteristic of a person or a thing that can be expressed as a number is called a variable. So this is how we are able to compute something, right? Because it has to be recorded as a number. And if we can record it as a number, then it's called a variable. That characteristic is called a variable. The value of a variable is the actual number that describes the person or the thing. And there's two broader types of variables. I've separated them into quantitative and categorical or qualitative. So to illustrate that, I want to propose or present to you two variables. Favorite restaurant is one variable, and number of passengers in a car is another variable. They're both variables that I can collect data on. I want you to tell me, though, what's the difference? What distinguishes one variable from the other? Okay, so let me provide an example. Right, so you guys are getting the idea. So one is what we call categorical or qualitative, and the other is quantitative. Well, why? Okay, first of all, so people who don't follow, what am I talking about? Favorite restaurant. Well, let me imagine you want information, you want to gather information on people's favorite restaurant. So you go with an iPad, or you collect data and then enter it into like an Excel spreadsheet, and you include observation as one variable or one column, and the second column is the restaurant. Okay, so you have observation and restaurant. So observation 1, 2, 3, 4, 5. And you ask people, as they're coming out of Plaza, you ask them, what's your favorite restaurant in the mall? Maybe you can say that. And then they'll say, I don't know, is Sizzler still there? So they say Sizzler. And then somebody else says, give me some restaurants. I can't remember. Is Fuego in there still? What is that called? Help me out here. Restaurants. There's that Asian restaurant. No comments? Restaurants in Plaza. Okay, yeah. Cheesecake Factory, that's a great one. Cheesecake. Okay. Red Lobster's still there. Wow, I haven't gone there yet. Olive Garden is in there? Okay, and then somebody else says Sizzler. All right, so these are people's favorite restaurants in Plaza. I'm not going to hold you to it if that's not your favorite. You're just listing it and helping me out, so I appreciate it. So I could ask more people with 3 dots. I could ask more people their favorite restaurant. And then what I do is I need to code. I need to code restaurant, and I'll call this restaurant num. And so Sizzler will get the number 1 just because that showed up first. Cheesecake will get 2, Red Lobster 3, Olive Garden 4, but then Sizzler will get 1. Say with the 6th person said Red Lobster. So that would be a 3. All right, so we use these numbers. Oh, Chili's, I can't forget Chili's. Oh, Chili's. and that would be 5. All right, so that's how it works. So that's how I get a number out of the values. Now, those numbers that I assigned, were they assigned in any particular way? Like if I went on a different day and started asking people as they leave Plaza, if I asked them on a different day, and I use the same logic in numbering, the numbers would be different, right? So on a different day, maybe the first person that came out was cheesecake, and I would have assigned them a 1 if I started my project on a different day. The numbering scheme I use in that way is subjective. From person to person or day to day, the numbering is subjective. So in that way, we refer to favorite restaurant, and for that reason, we refer to favorite restaurant as categorical or qualitative. Number of passengers, however, when I'm counting, the way I assign the numbers, I look at the people in a car at an intersection. So I go here which is actually very easy because the light is very slow by my place. It's Cesar Gonzalez and the Pinheiro. There's Walgreens here, and the traffic is very slow through there. I could actually count how many people are sitting in their car. And every time I count, the value I assign would be the same as another person counting the value that they assign, right? It would be objective how many people are counted in a car. So this, in this sense, it's quantitative. All right, so the big difference is that, well, that's the main difference. They're both different types of variables, but there's a further distinction, a subtype. I'm going to ask you, out of the last two, which one is, what's the difference between these two in terms of categorical and quantitative? Which one is categorical out of these two? Right, so you guys get it. Performance rank is categorical. So this is categorical. Okay, so it's categorical because, let's see, what's performance rank? Let's say it's rank in a job, and it's ranked by a few variables. You can include, let's say it was for a sales team, and it was assessed by a team of managers were assessing the performance of sales representatives, and it wasn't just the dollar sales they brought in, but other variables were included. So, if they had no complaints, or if there were their attendance at meetings, their availability, so other variables that go into this measure, and that's what makes it categorical. Okay, so you could put a bunch of numbers together to come up with performance rank, and maybe those that assessment could be different from manager to manager to manager, and assigning who's the best in performance would be a group decision. So anyway, performance rank in that way is categorical. It's not a fixed, it's not like with one measuring stick. It's established. It's a system that's established with a particular management team and they come up with an idea of how they're going to assess somebody. That's rather subjective, all right? Taking into consideration a variety of variables and excluding others. So that's categorical. Now, what's the difference between this categorical variable and this categorical variable? That's the subtype. So just to be clear, it's not like you can put a sales agent on a scale and measure them and then get a score and that's performance rank. No, a number of factors go in and the decision of what factors to include is rather subjective by the management team. So that's what makes it subjective overall and categorical variable. Right, Pablo, but still, the variables that go into calculating it are subjective, right? Unless it's completely based on sales, and that's it, in a sales team example. Okay, so Pablo says one is ordinal, so we have a distinction now. This value assigned here was not assigned at any, the number doesn't have any particular meaning. If a person who went to the person who said they like Red Lobster showed up first, I would have made, using this numbering scheme, I would have made Red Lobster a 1. So the assignment of the values is as no extra information. That's what makes it nominal, no or nominal. So this is nominal. That's different from performance rank. The very word rank implies order, and that's why the numbering here, or the assignment of the values, the person who was first ranked performed better than the person who's second ranked, and the second ranked person performed better than everyone who was ranked below them. So in that sense, order matters, and the value has a judgment or a meaning. Okay, the value actually has a meaning. So we call this variable ordinal. Questions so far? No comments? Okay. So, what about the other two? Whoa. What about the other two? The number of passengers in a car and temperature. They're both quantitative. What's the difference? What distinguishes one from the other? What is the subtype difference? Okay, so Temperature is quantitative because I use a machine, and another person can use a machine, or not machine, but an instrument, it's a better way to say it, an instrument to measure temperature, barometer to measure temperature, and they will get the same, as provided it's calibrated, they will have the same result as I would, right, at the same time. Their result could be a whole number, or it could be portions of a number, right? You can have a digital scale or digital instrument that has more precision. It could have decimal values on it if it's digital. So in that way, it's quantitative, but it's known as continuous because we can have fractions of a whole digit. That's different from number of passengers because passengers have to be whole numbers. The value of the number of passengers is between 1 and, however many people fit in a vehicle. So we call this, the word that we use for that is discrete. And the word that we use for this one is continuous. I'm going to fit it in here. Okay. My pen became thicker. I don't know why my pen became thicker. Okay. All right, so you guys feel like you get this is boring, maybe you think you know this. I'm going to give you 5 minutes to try your hand at these, identifying these variables, type and their subtype. And if there's any confusion, you can enter here on the side the values to clarify what it is you think of when you think of that variable, because there might be a little bit of ambiguity about what I mean. Okay, so let me give you 5 minutes to attribute the type of variable and the subtype. Okay, I'm back. So any questions about this? The answers are provided at the top on the next page. Any questions about any of these? So height of women should be quantitative and continuous, because even if you don't have a measuring tool with precision, you can acquire one. The number of whole hours a student studies is, the word whole is the tip that you want to talk about the discrete numbers. Okay, so remember, discrete are, well, 0, 1, 2, 3, and so on. The place of runners in a race, again, this is categorical, and the order matters, right? The first place is better than the others, so they have a meaning. The value assigned is meaningful, and further, an averaging of the numbers, well, maybe not an averaging, but you can interpret the numbers in a relative way. Averaging of numbers is reserved for quantitative variables as a meaningful measure. Place of numbers in a race, categorical and ordinal. A variable like this, where it's a response to, do you like multiple choice questions? A person can respond yes, no, or no comment. Let's say those are the options. And I assign 1 to yes, 2 to no, and 3 to no comment. But somebody else, another researcher, could assign 1 no comment, 2 no, and 3 yes. Okay, it could be assigned in a different way, and it doesn't affect an interpretation of any kind of results if you're to use the numbers. So then we get to the score on a test, right? So someone just wrote. So depending on what you assumed as the values, you would have said quantitative or categorical, okay? The way that I've done it, I made it a percentage or a ratio. So that's quantitative. But what if, and further, I made it continuous. I forced it to have a fraction or decimal here to show you it could be continuous. But if let's say the values were A, B, C, D, you can get those on a test. What would we say it was? What would we say? So it depends on the grading system. You would have to attribute the values of your variable to answer that question, okay? You'd specify the values. So in this case, these are categories. Sure, a certain ranking of values would put somebody in an A, and some, ranking of values. So this is going to be ordinal because an A is better than the others, and so on. So this would be qualitative, that's right, and ordinal. The main reason is that there's not just one number in A, right? There's many values in A. A person getting an A could have possibly 90 or 95. It's not just one value, so it's hard to pin down one value. It's a category of numbers. That's what makes it categorical. So it's a category of several numbers. Discrete, you mean score on a test? Could be quantitative and discrete. Sure, if you had written that the test score has to be So if you had said something like the test score had to be discrete, if you added a whole number, if it had to be whole numbers, then that would be qualitative and discrete. Okay, so we're going to step back to number 3. Let's settle number 5. Everybody okay with that? So whatever you put here will determine if you're right. Okay, so if this was a question on a test or in a quiz, the examples and the consistency between the example you provide and the type of variable you specify and subtype, the consistency would give you the grade. I'm just noticing that the video is really far behind my speaking. So I have to hesitate and look up to see the comments. Okay, so let's go back to the place of runners in a race. In one race, the runners would be, their score, like let's see how I can explain this. Okay, let's say, yeah, okay, so for one race, right, the person who got first place had a higher score than the person who had second and third, right? But let's say you combined, you know how they do racing and they do heats, right? And then they eliminate and they put, maybe they still use, I don't know if the Olympics, they still use the numbers. The best way to think about this is, for this to make sense, would be from year to year. So the data would look like, let me see, I'll move this over. So let's say we had a number of athletes, and the first person, let's say we assigned them numbers. So let's say we had a So this is data from a population of Olympic runners. And we have their year and then the rank for the, what is it? See, I haven't watched in so many years. So the fastest meters, is it 50 meters? 50 meter dash. In 1999, the first person that I looked up, their rank was, second, and then in 1999, somebody else, and their rank was first, and in 1999, somebody else, and their rank was, let's say, 13, and then, so I have all this data from 1999, and then, let's see. So then in 2000, well, it's not Olympics, right? There was no Olympic in, let's see, I can't write Olympics. I'm just going to say runners in an important race. I don't want it, because that's not an Olympic year. My husband will be furious. So bad with sports. So this is data from a population of runners. Okay, so I have all this information over years in some race, in some tournament, or track and field tournament. And so I have this information, you see? So what I have here is that different races were run over different years, and what makes you first place in 2000 is different than what makes you first place in 1999. And that way, it's subjective. It's a lot of work, right? It's ordinal and it's categorical, because all the first place winners, would be considered together. So everyone who wins a gold medal, for instance, in the Olympics, they're in a certain category, right? I think it'd be better just to make this place of Olympic runners or something like that. So to make it quantitative, it would just be to look at if I looked at, not their rank, but I looked at the speed, that would make it quantitative. So this variable is categorical. But this one is quantitative. If I actually look at the speed, because we can all measure the speed and we'll measure it the same way. That's like the time. I guess that's the right variable, not speed. So the one with the lowest time, like the fastest, okay, so then that's, and then we have the salesperson ranking as categorical. Now, why am I doing all this is the most important thing I want to gather from this. Why am I doing all this? I am distinguishing between the types of variables because the type of variable determines the type of statistics you can calculate. Once we're done with Unit 1, we're going to move to Unit 2 where we actually calculate statistics, and we are going to focus on quantitative variables. I am going to simply tell you that categorical variables are not analyzed in this class. If you have a categorical variable that you want to analyze, you just make a pie chart or a bar chart with your data. So for instance, responses to this question, do you like multiple choice questions, you would display or graph the observations to summarize them in a bar chart or a pie graph, if you know what that is, I hope. Okay, but we're going to focus in this course on quantitative variables. And units 2 to 6. Okay, we're going to spend some time talking about them here, but then we're going to focus on quantitative variables. The issue is, for categorical data and analyzing categorical data is something outside the scope of this class, but once you take this class, you can, as long as you distinguish what you can and can't do, you are ahead of the rest. I have had, sad to say, I've had students come to me in their graduate, PhD program and hand me statistics using categorical data, without realizing that you can't use the basic frequency statistics on categorical data. They have to be analyzed in a particular way. If you want to do something like relating variables to each other, it has to be done in a specific way. All right, so that's why I'm teaching you this, what you know and what you don't know. Right now, we're talking about these different types of variables so you can distinguish between them and realize that the techniques that I'm going to teach you are reserved for quantitative data. All right. If you have no more questions, I want you to try this one. Now, the answers are below. Try not to look at the answers. If you try this one, without looking at the answers, I'll give you a few minutes to read that. Okay? Again, if you have any comments, you can text me privately. You can write in the chat. All right, I'm back. All right, so let's work through this. This is a quiz. These are some quiz questions. No, sorry, these are like examples of quiz questions. All right. And if you're looking at the answers, you know the answer already, but let's dig into the rationale for those answers. So to familiarize yourself with a variable, you should try and respond to it or think about how you would go about measuring it. So this variable is asking, this question is asking, in which faculty are you registered? So this is like a survey that was taken. In this question, you have to respond one of these. So in your case, you would respond other, right, for Administración de Empresas. What kind of variable is this? Is it quantitative or categorical? Right, so this is going to have the type of categorical, and because if I was to assign numbers and I used the logic of just alphabetical order, I would assign Art 1, Continuing Education 2, 3 for Human Ecology, 4 for Science, and 5 for Other, let's say. Or maybe I would assign within other, I would create more values, 5, 6, 7, depending how many there were. Okay? And I have to decide now, does order matter? The numbering that I used here was done in an arbitrary way. Somebody else might want to number them according to larger size of registered students, so, and that still would be fine. So this would be categorical and nominal, or nothing, no new information, nominal. The next question is asking for how many glasses of milk do you consume per week? So think about how you would answer that. I don't know, I don't think I consume any, I think it's a half. Maybe you could look at several weeks and then average over those several weeks to put a number in here. So I already have the sense. I want to use a fraction. So do fractions apply? Well, it's saying how many glasses, and I'm saying half a glass. So for me, this would be quantitative because I'm actually giving a value. And if I was to demonstrate how much I drank in a week, everybody would agree on the value or the measure I computed. So I will say this is continuous because I could easily have a fraction. I spelled that wrong. For the next one, how dark is your hair color or natural hair color? What would you say there and why? Some people are saying that this one here was quantitative and discrete. If you saw it like that and you interpreted, students don't like when there's ambiguity, but that's reality, okay? So if you want to say that glasses have to be whole numbers, then you would say quantitative and discrete. But for me, it's not clear in the question, so I will be more generous and allow for continuity. So what about this one now? So think about how you would answer that. My case, my hair is, well, actually, there's brown, there's black, and there's gray in it. But okay, let's say the majority of the hair would be black. So you can see, yes, number 3 is categorical because there's the reason would be that the way that I assign the numbers, I could do it like I've done it here, where it goes by well, let's say it's categorical because these are not numbers and I have to assign numbers, right? So we'll say this is categorical. And people who fall into the black or brown or red, they're just assigning or aligning themselves, identifying with a category. But the way that the question is asked for the subtype, how dark, there's extra information. Like you might not have noticed, but you're not giving the best answer if you say that this is categorical nominal. The best answer would be categorical ordinal, since I should be able to capture the darkness of the hair. So I can use numbers to do that. I could say that smaller the number, the darker the hair. Or I could do it the other way around. I could say the higher the number, the darker the hair. The point is that the relationship between the numbers matters, and the ordinal relationship between them particularly. Okay, so that's categorical ordinal because it's how dark. It's a spectrum. Yeah. All right, so now the last two. Yeah, you need to refresh. See, my screen even fell behind. So you need to refresh if what I'm saying is not aligning with what you're seeing. Okay, so for the last two, it's the same answer. So how often do you usually exercise per week? And you're given 3 categories, right? Because here, less than once has different amount of time, like possible and less than once. Once or twice has 2 numbers in it. More than twice, that has several numbers in it. So this is not quantitative. I'm I'm connecting, or I'm combining quantitative or values, numbers, all into one category. So this is categorical for sure. Now the question, is it nominal or ordinal? Does the order matter? So in relative terms, in answering the question, how often? So more than twice is more often than less than once. Now this plays in, this order that matters here means that there's extra information. With extra information, we can do more with the statistics that we can calculate from here, all right? We won't be able to, like an average won't exactly make sense. If I was to take data, so if I asked a number of people, so you think about observations, so here's my values in Excel, I have my observations, and then I have how much they exercise, and let's say I assign this one 1, this one 2, and this one 3. So this person says they exercise less than once, this person says once or twice, this person says once or twice, this person says once or twice, and this person says 3 times. Let's say there's more data, maybe. Now looking at this data, let's say we just look at the first 5 people, and we just average these numbers. I think the average would just be around 2. Let me double check. Because it's going to be 6, 9, 10. All right, so it's just 2. So the average is 2. So that makes sense. But what if the data look like this? Like nobody had between once or twice, but when you average those numbers, you get 1.8, which is not representative of who appeared, and now you don't even know if that means, does that mean less than once or twice? We have trouble interpreting what that means and where to assign this average. Does it fall into, because this is categorical, we need to summarize as though the person's in a category. So it just becomes complicated making averages of categorical numbers. However, the ordinal nature is useful, and like I said, I'm not going to do analysis with this, but you could, after this course, look into how you would, do that, analyze that kind of data. This is really important, not just for me to distinguish continuous or quantitative data from categorical. It's also important because most surveys that you've ever seen are questions like this. If you've answered a survey, they're questions that are categorical. And so analysis and interpretation done with that data would have to be done in a specific way to be accurate. So if you collect data like this for a survey for your marketing firm, be careful about how you interpret the results. The last one, what would you say? So for the last one, this again is categorical because it's a range of values in each category, not a single value. So your values are ranges of values. Underlying the categories are values, but it's ranges of value you're dealing with. And the order matters, so it's ordinal, which makes certain statistics and interpretation possible that nominal categorical variables don't. Right, good. Okay. This is particularly difficult to interpret any kind of averages taken from these numbers. Okay, so that's that. So that's just an example of the depth to which we go. So you might have learned statistics before, you might have intuition about what I'm talking about, and that's great, you know. I'm just trying to tease apart what's true and what's not true, what we can, what we have tools to analyze and what we don't, all right? I do want you to count on your intuition. I want you to refine your intuition, really, about how to solve problems. Don't abandon your common sense and logic when doing statistics. A lot of this is drawn from a lot of common sense observation. All right, any more questions, comments? You guys get it? So most people get these wrong. Well, all three of these wrong. So don't feel bad if you had a little bit confusion, but hopefully it helps you see. Gerardo, what matters is the values. Okay, when you're figuring out the type and the subtype, it's the values. What are the values? So here the values are several numbers. That's how I know it's categorical. Here there's several numbers, not just a single number in the values. So each number assigned is not assigned to just one number. It's many values underlying it. And for subtype, the relationship between the values matters. If it's ordinal, then the number assigned has a relationship, and you have to be clear about how they were assigned to reveal that relationship. Like in here, if you just assign numbers and you forgot about the fact that you could capture one is darker than the other to do some sort of analysis, then you missed some information. Making it nominal is not the best answer. All right, so it's 11 o'clock. So I'm going to leave this for you to read. It's another way of looking at data, but seeing the ranking. Nominal having the least, offering the least amount of information, ordinal offering a little more. Interval type data is discussed here, distinguishing it from ratio type data. So it separates the types of quantitative data different from just saying discrete and continuous. So you can have a look at that. I don't focus too much on this distinction, but you can look at that. So in my notes, I don't want to say omit it, but this is just extra. Maybe I can put that on here. I won't test this concept. This is just extra. right, so what I want to do next, if you don't have any questions, is I want to talk about the topics presented in the videos. So now that we understand, distinguishing between types of data, like I mentioned, after this unit, we're going to exclusively work with quantitative data. Although, I will talk about categorical data, but I'm not going to do any calculations with categorical data. If you haven't watched the videos, please, you will need those. You'll need to watch those to understand what I'm talking about. And those are found in the playlist Decisions Through Data. I think I just called it DTD. Allow me to put the link here. That link will take you to the playlist. And I also had, I think I gave you a neater link, a tiny URL one in the note, in the syllabus. So those videos are rather old, like almost 30 years now. Let me think. They're from 1992, I think. So that's 30 years. So they're they're old, but the contents are still relevant for fundamentals and statistics. That hasn't changed. And I haven't found anything superior to these videos to introduce these topics. To help you remember what you saw, I've developed these notes. The idea being to emphasize and highlight the main concepts, right? So you learned about observational studies and experimental studies, where by observation, ideas or hypotheses could be formed in trying to attribute or to suggest certain relationships exist between variables. So cause and effect, one variable affecting another variable, shouldn't be, it'll be difficult simply by observation to derive a relationship or to imply a direct relationship. We use experimentation for that. We use experimentation to assess a cause and effect relationship. So the video begins with talking about experiments and data collection and design of experiments, and then it goes into survey design. And the idea is the surveys are for observation purposes. All right. So we use observation to help derive hypotheses that it can then be tested in experiments as much as we can. Now there's going to be barriers to being able to do that. There's obstacles often in creating experiments, and a description of an obstacle was when they discussed actually conducting an experiment to see if smoking causes cancer. And they proposed in the video the best or the gold standard of an experiment would be to separate children at birth, assigning them randomly to both control group and or placebo group and to an experimental or treatment group. So control group would not be exposed to smoke, and the other group would be exposed to cigarette smoke, and then analyzing over time how they perform, what their health outcomes are. Now this is completely unethical. We don't, when we suspect harm, we don't have the authority or we don't have the right to impose harm on experimental subjects. And so those kinds of experiments would not be conducted. And so in that case, we rely on observation. And there are amazing things you can do with observation. The Census Bureau in the United States collects a large database. Every year adds to the database. And then every 10 years conducts a huge census where it attempts to count everybody. But in the interim years, it collects all kinds of information. And I've actually analyzed that data in the past. Census Bureau has many different types of surveys for health and employment and things like that. So those are excellent observational databases, but you have to have rather expertise in knowing how to clean the data, prepare the data to be able to draw conclusions, any kinds of meaningful conclusions. And any sorts of associations you draw, you refer to them as that. You cannot imply causal effect in observational data. However, we're going to go through it and we're going to talk about what you saw in the video, where you saw that even in the case of smoking, without the experiments being done on human subjects to determine the cause and the dose-response relationship between smoking and cancer, the Surgeon General of the United States was able to claim that smoking does cause cancer in the 60s. And we've ever since, we've worldwide believed that or accepted that. All right. Thank you, Alec, for the comment on the videos. They're very good videos, I have to say, for myself, so I keep showing them. All right. Let me say it now before I forget. I want to just make a point about distinguishing between the results of observation and the results of experiment. They could be different, right? An observational study could tell you one thing, and then upon experimentation, you find something else. And the example for that The example for that is hormone replacement therapy experiments. So in the, I think it was more in the 80s, female patients were being treated by their doctors with hormones upon having claimed or complained about symptoms of menopause. So menopause symptoms can be terrible. They can mean migraines, and that's nausea and headache. They can lead to hot flashes. tremors, very debilitating actually. And so women were finding themselves at an impasse, trying to work and experiencing these symptoms in their late 40s and early 50s. They sought help from their doctors, and doctors were prescribing them hormones. So these are sex hormones like estrogen, testosterone, and progesterone in various combination to help treat or calm their symptoms or relieve their symptoms. So this was being done for a decade or so before there were actual experiments to prove this was effective and safe to do. So upon conducting these experiments, once the experiments were derived, soon after so in the experiments, people are invited, volunteers are screened, and they are randomized into experimental and treatment groups. It turned out soon after that they were realizing on a variety of different health outcomes, the patients were not performing well. They were showing particular signs of cancer in elevated signs of distress or problems in the treatment group relative to the control group. So the trials were dismissed, and doctors were cautioned about giving hormone replacement therapy just to any patient. So how could this have happened? How could observational study be so different, the results of observational studies be so different than actually conducting an experiment? So observational studies were done in the past that showed women on hormone replacement therapy were performing well, their symptoms were alleviated, and they were able to work. And then in experiments, you see terrible health outcomes that were not picked up in the observational studies. So what could have happened? Well, these were explained away by the idea of self-selection. So it's the women who were approaching the doctors who were the more informed women, the women with higher education, more income. These are variables that are also associated with better health outcomes overall. They had a better lifestyle, they had better exercise and diet choices in their routine. So these women performed better overall with the hormone replacement therapy because they were not at elevated risk of any other kind of health condition. So it turned out when you invited people from the general population to receive hormone replacement therapy, and this is an explanation of the possibility for the discrepancy between the results, when you invite just the general population, it's not the same. Okay, so this doesn't mean hormone replacement therapy is bad. It's just that doctors had to take more precautions in administering it, not just administering it to every subject. They'd have to be sure that their patient was able to maybe track their symptoms. When you take hormones, when a person takes hormones, it has to be monitored regularly, and that costs money. All right, so maybe people who don't have the financing aren't going to monitor, or they're not going to be able to take time off work or be able to do the things that are necessary to do the monitoring and receive the proper treatment or adjustment to treatments. Pablo, I didn't know that about birth control. You want me to talk a moment about moral hazard? So here, I was mentioning the difference between a placebo effect and a Hawthorne effect. In the video, they explain or describe the Hawthorne. They describe both, but just to distinguish between the Hawthorne and placebo. The Hawthorne Effect is where human subject, as part of an experiment, will change their behavior because they're being monitored. Now, some patients, if it's a health study, they might perform, or they might change their behavior in a positive way. So they know they're going to be asked questions about their diet, they're going to be weighed, they're going to be measured with a measuring tape, their waist will be measured, their where fat accumulates around their hips will be measured. And anticipating this, some subjects will change their behavior. Maybe they'll in a positive way, so they'll be more likely to exercise and eat properly because they know they're going to be weighed, or they might not eat the day that they get weighed or something like that. They'll fast, or they'll use diuretics, so they might change their behavior in I don't say that's a positive way, but in a way to manipulate the results of the outcome, and with the idea that they want to perform or feel better. Or they could change their behavior for the worse. They might be rebellious, right? Knowing that they're being monitored, they might act out, right? So some people, when they're being told what to do, even though they've selected to be part of the study, they have to volunteer to be part of the study, they might just feel too much pressure and binge watching Netflix or something, and jeopardize their health or their outcomes as measured by the researchers. So whatever it is, the behavior changes might affect the outcomes that are being measured just because they're part of the study. And the way that we'll see that is that the control group experiences the reason for the control group is so that we can pick up any kind of changes and create a new baseline. So whatever the case, if you have people who are changing their behavior for the good or for the bad, you have just as many of those types of people, we imagine, in both control and treatment group, so that when we look at differences, we're using the control group as a baseline. I'll talk more about this in a bit. That's different anyway. The Hawthorne Effect, the idea of humans changing their behavior, is different from the placebo effect. Placebo effect is not a behavior change. It's something that happens in the perception of a person in a study that gives them a sense of well-being or positive, hopeful feeling, that maybe endorphins are released in their body, and the biochemistry of the person changes to otherwise relax them or reduce their stress, and resulting in better health outcomes, whatever is being measured. So the placebo effect is actually human subjects, noticing that human subjects in a control group of an experiment, because of their very belief in the positive outcome of the treatment, experience positive health effects. But otherwise, they did not receive the treatment. Just like in the Hawthorne Effect, people not receiving the treatment having health outcomes attributable to the treatment that they didn't receive doesn't make much sense. Okay? So placebo is different because it's just the belief that makes it so. In the Hawthorne Effect, there's actual actions that make it so. When I mentioned moral hazard, this is something that could be studied. So, just like the placebo effect and the Hawthorne effect, we know they exist because we see control groups changed behavior without even having actual treatment imposed. In non-natural type of experiments, where, for instance, we want to see the behavior of people with insurance. If we want to look at the behavior of people with insurance, this is more of a social science type of experiment. They're not as common, but there was one conducted in the 70s by the Rand Institute. Where households were assigned, they were given different types of insurance, health insurance, and their behavior was observed, or their outcomes, health outcomes and behavior were observed over the next few years. And one thing they tried to look at was moral hazard. Do behaviors change? In the case of insurance, are people less precautious than they would be without insurance? So did the behaviors change? And they found modest evidence of moral hazard, but this is really hard to capture or pick up. However, the beliefs about moral hazard vary without evidence. We make certain assumptions. In Canada, the viewpoint is that it doesn't matter. Even if people change and they're less precautious when they have insurance. So what that means is somebody with health insurance won't bother to watch what they eat. They won't bother to exercise because they have the insurance, and the insurance will pay for any kind of drugs or surgeries that they'll need. So in Canada, they don't care too much about the risk of moral hazard. They say it's more important. They prioritize access. And so health insurance is universal. Anyway, I could do a whole course, and I have done a whole course on Canada, Canadian health insurance and health insurance in general, talking and comparing it to the United States. So I won't say all of that right now, but I'll just say the perception in the U.S. is that this is important, that although Canada cares about access, the United States is more concerned with maintaining affordability or costs, or let's see. The solvency of the insurance system. Anyway, I don't want to get into that too much, but the point is, it's hard to study that. But it's still something that any kind of research has to be aware of behavior changes in the subjects that will affect the outcomes. Yeah, it's very interesting. So if you learn anything, if you learn nothing from me, let's say, at least learn to ask for the assumptions, identify assumptions, right? Any kind of study that you read about results, when people speak you hear news reports, they're just sound bites. You hear sound bites a lot in the news. It's better to read a report. I know we have limited time, but it's better to look for what are the assumptions they're making when they're saying these things. It's really important. So let's get back to this class. So in many ways, science is just speculation until it can be confirmed by measurement or experimentation. Statistics is a tool that helps measurement through survey analysis or experimentation to produce knowledge and to clear up confusion. And I would add, help make predictions, right? Statistics is concerned with producing new data as well as with interpreting already available data. You can produce data for either an experiment or observational study. So I just mentioned here, I asked you just some questions just to help you recall the video. The point of that is to help you remember the point being made. In this case, an experiment, so the point is, what is an experiment and how is it different from an observational study? In an experiment, you deliberately impose a treatment on individuals in order to observe, or subjects, in order to observe their response. And I ask you for examples in the video, and I propose that the answers are here. The ink in the lobster tank, to observe the change in behavior, the ink is the treatment. So you can observe lobster behavior before you put the ink and after you put the ink, and see if there's, by blurring the vision of the lobster, does it change their behavior. Then the other examples I mentioned were the tar on rats, to see if a carcinogen on this rodent causes cancer. And then there was the physician health study, that's the aspirin study. Examples of observational studies include the surveys or census or focus groups that were displayed in the video. In the observational study, the individual is observed and variables of interest are measured, but there's no attempt to influence any responses from the subjects. So there was the study of observing all lobsters, there was the general social survey of the NORC, National Opinion Research Center, and there was the census on the homeless. Those were all observational studies that were mentioned. They also mentioned two types of studies. There's the retrospective study that uses data from the past, and prospective study that follows subjects forward for a number of years from the start of the study. Okay, so students usually don't like this terminology. I have to clear it up, so I'm going to take a little time discussing bias. A survey or experimental design is said to be biased if it systematically favors certain outcomes. So a finding is known to be biased upward. So if you're trying to measure a variable and the responses tend to be higher, more or greater than is actually the case, you have an upward bias variable, just by the very way it was collected or intended. So I present some examples in the video. Why don't you guys tell me in the chat if you remember examples of upward bias, or you have confusion about upward bias. So it really matters how I write the expression or the sentence. I can flip it so it says upward or downward bias. So for instance, Ann Landers and Landers had a voluntary response survey asking people. Oh, you wrote something. Alex says if richer people are more likely to answer income questions, that would be upward bias to it looking like incomes on your sample are high. Actually, I actually think it would, I mean, I don't know for sure, but my impression is people with higher incomes don't like to disclose their income. So that's why you see in a lot of surveys, they always say 50,000 or higher, or 100,000 and higher, because those people are the least likely to disclose. And to avoid them being a non-response, because that really messes up your survey, you just make a broader category that they're not resistant to responding to. But that's an example, yes, upward bias. Very good. So downward bias is the opposite, or I was saying something, wasn't I? And Landers asked people if they would have kids again, and the overwhelming response was no. So that was bias upward towards no. 70% said no, they wouldn't. But then an independent random sample was taken where people were sent, or they were randomized and approached in a systematic way. So that result showed that 10% said no, not actually 70% that she got on the voluntary response. And that's explained by the fact that people who voluntarily respond to things are usually often people who are passionate or, upset or emotional about the subject. And so that the way she asked it, she attracted people who are disgruntled about having kids and they didn't want to have kids again. Yeah, Pablo, that's it. So it could be of a high amount, or it's bias upward. So the way he said it is it's a high amount, but bias upward towards, so I say 70% said no, so it's bias upward towards no. So it's the percentage that makes it high. So it's the way you phrase the question or phrase the statement. I could flip that and say it's biased downward, downward bias against yes. The less people said yes. So bias down examples would be people were less likely to say they enjoyed sex after marriage. Only 18% of respondents said they enjoyed it. So there, it's low, downward biased against the statement. So the number is 18%, but that's not in fact true. That's just because, again, disgruntled people are writing in. Okay, so if you ask the question, if you were to marry your spouse again, would you do it? If you did it in front of the spouse, Gerardo. If you were, let's say, in front of the spouse, you ask the question, would you marry them again? What would be the answer? It would be yes, right? So that would be upward bias for yes. because you wouldn't want to tell the truth if you weren't happy in front of your spouse. Okay. Alec asked, can results be 100% unbiased? Good, that's a good question. Probably not. You have to identify, so, in any study, where data are collected and a report is written, there's always a section of a report that states limitations, and that's where all the limitations of the variables go. So limitations that create bias. And what you can do is, if you can explain the effects of the bias, or that the bias kind of evens out, like in the example, well, we're going to get to it. If there a potential for bias to be created, you have to discuss the potential and how it might have affected your results. All right, so you spell it out, and you can maybe provide a range of values of interpretation. Today I'm hitting my microphone a lot. I'm sorry about that. I'm being sloppy. I don't usually touch the microphone, so I'm sorry if that is making a loud noise on your end. So the other question was, the summary of that is just that most studies have bias in them, and the goal is to identify it. You can't avoid bias completely. We wouldn't have any studies. All studies have flaws. Okay, so it's just a matter of mentioning where the bias could be and what it did to your results, and if it's not extreme, you can have meaningful conclusions, and you can even prepare a report with a conclusion that's ambiguous. People publish papers with ambiguous results. How do we know if a design is systematically biased? Well, that's a very general question, but you would have to go through, through the particulars of the design. So we are assuming, we're coming up and saying this is not possible with anecdotal evidence. 70% of families would say they would not have children again is a stretch. So yeah, I am making an assumption, and I could study it. And so what was done is an independent random sample was created and showed it was completely different. And so the bias was determined. So the idea of random sampling, random assignment in experiments or random sampling in surveys is to limit the possibility that there would be systematic bias that will affect your results. So how do we know if it's systematically biased? Just by seeing the results, you're trying to explain it, and maybe conducting or asking a question in a different way, and seeing the comparison. That's how. So sometimes surveys are created with many questions. I think they talk about it in the video, the way they create surveys and the way they test the surveys, where they have a question, so you have like a survey interviewer asking a participant to try and answer the questions and think through the questions, and they get an idea of the thoughts that a question generates. So sometimes in surveys you'll see 2 or 3 questions that are similar but asked in a different way, so they can capture any variation between the responses. This is a preliminary course in statistics, but it does touch on a lot of the topics, and you can imagine these are creating a survey that's meaningful is quite the enterprise. It's not as easy as it looks, but it's doable, and it's been done. And there are statistics developed to develop better and better surveys and better questions for a survey. So yeah, to develop a good survey, as I mentioned, they go through a process. The questions go through a process, and you can pilot a survey, and you can ask several questions that capture the same thing, and see how how often people answer the question in the same way, and you can see a pattern, and then there's a process of validation or validating your survey. The peer review process has its place, but there's so many things you need to do before you just you need to validate a survey before peer review. You have to do the due diligence, I'd say, before you send it in for publication. Any results of a survey that you claim is valid. I can't spend too much time on this stuff on this class, but you can imagine you can take a whole course in developing surveys. There's a lot of really good classes offered through the education faculty, and often I send my students, or students are sent there to take classes in designing questionnaires and surveys, as well as other kinds of statistics classes. The question, is there ever a benefit of doing voluntary response versus random sampling? It's just sometimes you won't feasibly be able to random sample and be sure that respondents will answer your questions. So conducting voluntary response is a first step, getting an idea, formulating a hypothesis, and then with the means, with the resources, either getting financing to do it. Like, all this stuff costs money, because time is money. Developing a sample design, getting a framework, and then numbering, labeling all your units, and choosing, and then ensuring that those people are going to respond to your surveys. It's just much more efficient to do a voluntary response and then write in all the disclaimers about the possible systematic bias, and try and develop it in different ways, to avoid those biases, than actually doing a random sample. So yeah, there are places where it can be done more effectively than random or let's say cost effectively, because random sampling could be very expensive. Like, how are you going to get all these names of people to be able to reach them or contact them? You'd have to go through an institution that has that kind of information. They might ask for a cost. They might ask for money. Often you get surveys from students. I get them emailed to me, and I don't have time to participate. I know what it takes, and I feel bad, but occasionally I will engage myself in answering surveys that are sent to me. I'm talking about through Cartero and the university system. I get these surveys. So I hope I've answered all your questions. Yes, well, we'll do more with that. The idea is, if we needed a perfect study to be able to publish it, there would be no published studies. But you have to do your due diligence to get out all the snags and glitches as best you can, and the biases, before you try and publish or use a survey and then publish the results. Okay. So how does data get produced? So there's two major sources of randomized data. That's the one from experimentation and the one from surveys. Experimentation is conducted to develop evidence to support a causal link between an explanatory and a response variable. And I just go through here the ideas of the key points regarding experimentation. The idea for experiments is to intervene and so to measure the response of the subject to the treatment. Experimentation is done more frequently in the physical or pure sciences, not so much in the social sciences, but it's more so these days. There's economists that are conducting social experiments, and there's lots of marketing studies. Insurance is really important to study, but it's not done as much as it should be as an experiment. Mostly because people who are in an insurance experiment know that it's temporary. So it's hard to gauge what would happen in nature if they actually observe. It's hard to do a double-blind controlled experiment with insurance setting. Where some people get a certain amount of insurance, some people get better insurance, and so on. It's really hard to keep them from knowing they're part of an experiment. Or to act like they would in the natural environment. It's really important to actually conduct the experiment properly. If you don't and instead rely on information that looks good, you can run into problems. When the experiment is not pure, responses can be confounded or confused by lurking or overlooked variables, which can play an important role. And make sure it's random and not just haphazard. Random is a very specific term in statistics, and you learned from the videos what it takes to randomize a sample. I wanted to say something. Oh, in terms of some good reading, I don't know if maybe there's students who like reading, or even in YouTube. Dan Ariely he's a behavioral economist. I think that's what he is, but he's an economist anyway. But he does a lot of psychology experiments that are very interesting. They might interest you. You can check in YouTube, and he has books on rationality and irrationality of humans. Okay. So I asked you for examples of experiments in the video to help you recall. So memories are created, right, when you recall. I'm just asking you to recall these things so you remember them more vividly than reading a textbook. So different from the other ones that I mentioned earlier as experiments, there's this, I did actually mention this, the theoretical experiment of the effect of cigarette smoke on newborns, following them prospectively to adulthood. Those are all experiments. That and the tank, the ink in the lobster tank, as well as the physician health study and the tar on rats. Then I ask you, what are two key differences between designing surveys and designing experiments? The main one that you need to know is that in experiments we actually treat the subjects in the treatment group or with the treatments. If they're human subjects, we need to control against the effects of possible placebo effect. But in general, we use a treatment for the experiment to see the effect. Controlling for any other kinds of explanations of a response in the process. So that one we know. The other thing I mentioned here was the idea that gathering subjects for an experiment, if it's human subjects, I'll distinguish for human subjects here. This is in general, though. This is in general. So the idea that you impose a treatment. And with surveys, you don't treat them, but the randomization is a little bit different. When you randomize, individuals for experiments, you use all the eligible participants. So you invite people to an experiment and you screen them if it's a medical or treatment type experiment. You screen them, make sure that they're eligible and it's safe for them to be involved. And then you label them and use a random digit generator to assign them to treatment and control group. In other words, you use all the subjects that you can, right? When it comes to the survey, you label all your subjects, but you might not use all the participants. You might just choose a sample from the ones that you've labeled so that you have people that are selected in a non-systematic way. Okay? So if it was people that you were observing who showed up to be volunteers for something, you would label them with numbers and then randomly select from amongst those volunteers, but you might not use them all. So that's the main thing I'm going to say as the difference. So in the case of surveys, you select participants into the survey, but in experiments, you use all the ones that present themselves. Okay? So that's a distinguishing feature for human subjects, I'd say. Okay, so, I just crashed. I have to clean up. I have too much stuff on this. I don't know if I can turn the page. All right, so we're going to pick up here next week. You guys can read through the notes. Now you have the Moodle page and you can read through the rest of the notes. And next week I'll complete the presentation of Unit 1 and begin Unit 2. So you need to have that calculator that I asked you to get for this class. It will help you make calculations quickly. You can also use Excel in this class. I'll permit it for the tests. But we should be able, in the first hour and a half, we'll be able to finish this and we can start Unit 2 next class. All right, so read through this, try the quizzes online to test your comprehension. We're halfway through because the notes go up to page 23, and then there's just practice assignments to complete. So you see I've marked up the answers so you can basically self-study the rest of the material, and we can go through this and I'll highlight in particular, lurking variable people are confused about sometimes, and some other things I want to highlight. Do you have any questions for me before I go? Let me just show you the Moodle page and what I expect you to do. So for next class, for this week, work through the homework, try the assignments, and the quizzes. So there's your work for this week. And read through the 12 page, I think it's 12 pages prontuario, to make sure you agree to all the terms of the class. And we'll say today was officially the start of the class. Last week it was just a brief intro. Okay, so I'll take your questions now and I'll stay on. If anybody has to go, go ahead. So yeah, so Pablo is making some comments about that you can use your phone to take the quizzes and see the notes. I'm still here. Have a good weekend. Thank you, everyone. Thank you, Gerardo. Have a good weekend and a good week. We'll see you next week. Be in touch.